In this video, I'm going to give you guys a quick, easy way to memorize the solubility of common ions. So this is important because salts are made up of ions bonded together. So if we want to determine the solubility of salts, as we're often asked to do in chemistry, we need to know about the solubility of the ions of which they are made up. So this is going to be a chart for water at room temperature. In other words, we're putting these ions in water at room temperature and checking their solubility. So if you change the temperature or if you change the solvent, you're going to change the solubility. So I've got the soluble ions up here in blue and the insoluble ions down here in red, with the exceptions up here in red and the exceptions down here in blue. So let's go through these. So the mnemonic for soluble ions is BC1 NaSH. So for example, bicarbonates, so a salt with bicarbonates is like sodium bicarbonate, so NaHCO3. That would be a soluble salt because it's made up of bicarbonate. Any salt that's made up by a bicarbonate ion and some other ion is going to be soluble. All chlorate salts are soluble, so a salt with chlorate in it, like sodium chlorate for example, would be soluble. Group 1A ions, so any salt with sodium, lithium, potassium, rubidium, or cesium, these are all soluble salts. And the same holds true for nitrates, that's what the N stands for, ammonium for the A, and acetate. So any salts containing these ions are always soluble. So the last two here, sulfates and halogens, these have some exceptions. So in general, salts made up of sulfates and something else are soluble, except with silver, strontium, calcium, magnesium, and lead. And the little mnemonic that I gave you guys to remember the exceptions here for sulfate salts are some strong calcium metals persist. And that is for silver, strontium, calcium, magnesium, and Pb for lead. So anything with a sulfate in it, any salt with a sulfate in it is going to be soluble unless it's with any of these things. And then H stands for the halogens, so chlorine, iodine, and bromine. Any salt that contains those halogens from group 7A is going to be soluble unless it's paired with silver, mercury, or lead. And the mnemonic for that is some metals persist. So for example, if you had silver chloride, that would not be a soluble salt, because even though it's got chloride in it, which is usually soluble, it's got one of the exceptions here, silver, bonded to it. So then for the insoluble ions, I've got CSCPH for certain salts can't possibly hydrolyze. And that's really what something is doing when it's dissolving in water. It's being hydrolyzed. So these are the insoluble ions. So the first one is carbonates here. So most carbonates in salts, most carbonate salts are insoluble, except if the carbonate is bonded to a group 1A element or ammonium, NH4+. And the mnemonic for that is A1A for ammonium and group 1A. So for example, calcium carbonate would be insoluble because calcium is not group 1A or ammonium. But sodium carbonate would be soluble because sodium comes from group 1A. It's one of the exceptions here. Okay, and then sulfides. These are in general insoluble salts if it contains a sulfide, unless the atom or group that it's bonded to is from group 1A, ammonium, or it's strontium, calcium, or barium. And the mnemonic for remembering this exception is A1A plus strong calcium buddy. So if it's got strontium, calcium, or barium bonded to that sulfide, it will be soluble. Similarly, if it's got ammonium or a group 1A element attached to the sulfide, it will be a soluble salt. Okay, moving on to the chromates. So these are in general insoluble unless it's got this A1A exception, unless it's bonded to ammonium or a group 1A element. So for example, ammonium chromate would be soluble because it's an exception to the insoluble general rule. Phosphates here, PO43-, these are in general insoluble unless we've got that A1A exception. So again, something like sodium phosphate would be soluble, right? Because it's a group 1A element, sodium is. But calcium phosphate would be insoluble because it's not, calcium is in group 2A and it's not one of these A1A exceptions. Finally, we have the hydroxides. In general, hydroxide salts are insoluble unless they're bonded to group 1A, ammonium, or strontium, calcium, or barium. The same exception as we had with sulfides. So the mnemonic here is A1A plus strong calcium buddy. So as an example, calcium hydroxide, for example, would be soluble because that's part of the exception. On the other hand, any other group 2A element besides strontium, calcium, or barium would be insoluble if it was bonded to a hydroxide because that's not part of the exception. So I hope this helped you guys out, and I'll see you in the next video.